Hello everyone, in this video we're going to talk about how we can find the inverse of a linear function. So about 4 things we're going to read through, just to like some parameters, some guidelines for us to kind of think about and consider as we work through trying to find the inverse, and then we'll do an example together. It says functions that undo each other are called inverse functions. So that's our basic definition of what an inverse is, functions that undo one another. So basically what's happening is we're doing the inverse operations in reverse order. So when we talk about graphing, the graph of an inverse function is a reflection, and it's a reflection of the graph of the original function, and our line of reflection is y equals x. So remember, that's a diagonal line, it's proportional, it goes to the origin, has a slope of 1 and a y-intercept of 0. Now to find the inverse algebraically, we just switch the roles of x and y, and then we solve for y, right? So if we have like slope-intercept form, y equals mx plus b, we're just going to switch x and y, so it would look like x equals my plus b. And then we want to solve that new equation back for y, and that would be our inverse. So now when we think about that, what are x and y? What are some other terms that we have for x and y? Well, one of those is domain and range, right? So because inverse functions interchange the input and output values of the original function, then the domain and the range are also interchanged, right? So we know x and y, it means the same thing as input and output, which is also domain and range. So if we're switching the roles of x and y, then we are switching the roles of the input and the output, or we're switching the roles of the domain and the range. So essentially the domain of the original function will become the range of the inverse, the range of the original will become the domain of the inverse. All right, so let's look at an example that we have here. It says find the inverse of f of x equals 2x plus 8. So we're going to do this algebraically, but then we're also going to graph to see what it looks like. So we want to find the inverse. So the first thing I'm going to do is change f of x to y. So I'm going to write this as y equals 2x plus 8. Okay, that's kind of step 1. Step 2, now let's switch the roles of x and y. So now let's write it as x equals 2y plus 8. And now I want to solve this equation for y, or I want it to get it back to being y equals. So I'm going to undo the 2 operations that are happening to y. So the first thing, I'm going to subtract 8. So now we have x minus 8 equals 2y. And now we're going to divide both sides by 2. So we divide by 2, we divide by 2, and we get y is equal to x minus 8 divided by 2. Okay, so we can leave it like that, or we could write it like y equals 1/2 x minus 4. Either one of those would be a good equation for our inverse. Okay, so now let's graph our original function here in purple, and then we'll go back to the red color and graph our inverse. So our original function was 2x plus 8, so I would put my y-intercept at 8, and my slope is 2. So I could go up to right 1, or I could go down to left 1. So I'll put some dots on here, and then we'll connect these dots to form our original f function. Okay, so that would be my f of x function, right, which was 2x plus 8. Okay, now we go back to the red color. Let's graph our inverse that we had here, which would be 1/2 x minus 4. So I'll put my y-intercept here at -4, and then my slope is 1/2. So I'm going to go up 1 and right 2, up 1 and right 2, up 1 and right 2, up 1 and right 2. So now when I draw my line, it's going to look like this. Okay, now might not look like inverses right away, maybe because of how my graph is situated with my axes. But if we draw in our line of reflection, which would be this diagonal line right here, which is y equals x, right? Let me make it dashed for us. Okay, so now we can see that if we were to take the f of x function, which we graphed in purple, and fold it over that line of reflection, it would map on top of our red graph, which we have here. So a couple points to think about, or if we remember back in geometry, we know that if we reflect over y equals x, then it basically just switches our coordinates, right? So x, y becomes y, x, right? Which is the definition of an inverse, which we're looking at here, right? That's why a reflection does that. So we're making that connection to geometry a little bit. So if I think about, let's say this point right here, -1, 6, right? I should have a point at 6, -1, right? And there it is. Or if we go over here with our x-intercept, -4, 0, then our y-intercept for our inverse should be 0, -4. Okay? And so that is how you can find the inverse of a linear function.